Hi, this is Enavin, rule number 49, and my topic is about describe finite automata. Here we see the what is finite automata. Finite automata is a mathematical model of a digital computer. It is used to recognize patterns within input taken from some alphabet set. It consists of discrete inputs and outputs. Input given to a machine is processed by various states. These states are called as intermediate states. The job of finite automata is to accept or reject an input depending on whether the pattern defined by the finite automata occurs in the input, and it mainly consists of discrete inputs and the outputs, and followed by the sum of the transition rules and the set of inputs, set of outputs. Input given to a machine is processed by various states. These states are called as intermediate states. Here we see the structure of the finite automation model. In this, we contain the input tape, finite control. From the input tape, the control head will be there, and it will produce the output, and it will contain a storage. Input tape, it is a linear tape which holds the input string. The tape is divided into a finite number of code. Each cell holds a symbol from summation. Finite control, it indicates current state and decides next state on receiving a particular input from input tape. It consists of three things: finite number of states that the machine is allowed to be in. Zero or more states are designated as accept or final states. A current state initially set to a start state. A state transition functions for changing the current state. Storage, automation have temporary storage which has unlimited number of cells. Control head or tape head, it reads symbol from input tape and moves right side with or without changing the state. This is about finite automation model. Here we see the definition of the finite automata. Finite automata is a collection of 5 tuples. M is equals to Q summation transition Q naught and F, where the Q defines the finite set of states, summation defines the finite set of input symbol, and the transition symbol defines the transition functions. That is, Q into summation gives Q. This is known as the transition function, where it matters the in the TOC. Q naught is known as the initial state and F is known as the final state. These are the 5 tuples of the finite automata. Transition diagram. It is a directed graph for finite automata. If there is transition from state P to state Q on input A, then there is an arc labeled A from state P to state Q in the transition diagram. Example, initial state is represented as the following symbol, and accepting states are represented by double circles. The initial state will be represented by the single circle and the final state will be represented by the double circle. Here we see the problems in the finite automata. Design finite automata which accepts the only input 1 0 1 over the input set. Summation is equals to 0 comma 1, and the solution is the language accept only string 101. So L of M is equals to 101. In this, the initial state is Q0 and the final state is Q3. and the first input string is 1, and if we insert the input string 1, then it will change the state from q0 to q1. And if we insert the 0 input, then the at present the string is in the q1, and when we insert the 0, it changes from q1 to q2. And finally when we insert the 1 input, and the present state is in q2 state, and if we insert the 1, then it will change the state from q2 to q3, and the q3 is the final state. Here we see the design FA, which checks whether given binary number is even or not. A binary number is even if it ends in 0, else the number is odd. Binary even number 2 is equals to 10, 4 is equals to 100, 6. Binary odd number is equals to 1 is equals to 1, 3 is equals to 1, 11, 5 is equals to 101, 7. Here we see the transition diagram, and the initial state is q1, q0, and the final state is q2. Here, design finite automata which accepts only those strings which start with 1 and ends with 0. And the possible strings in the language are lf1 lm is equals to 1, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0. And in this, the initial state is q0 and the final state is q2. When we insert the 1, the state changes from q0 to q1, and when we insert the 0, the change should go to the final state, that is q2. So it is changing the state from q1 to q2, and it should satisfy all the conditions, and we have to write the 5 tuples for this also. Here, design finite automata which accepts odd number of ones and any number of zeros. The solution, the possible strings are lf m is equals to 1 0 1 0 1 0 0 0 0 1 0 1 0 1. And in this, the initial state is q0 and the final state is q1. When we insert the 1, the state changes from q0 to q1, and when we insert the q0, the state goes to itself, that is q1 to q1, and which is also known as the final state. This is the transition diagram for this solution. Design finite automata which checks whether the given unary number is divisible by 3 or not. Given that automata has only unary number, so summation is equals to 1. Number should be divisible by 3, so automata accept number of ones in multiples of 3. The possible strings are lf m is equals to 111, 111, and 9 ones. And in this, the initial state is q0, and there is no final state in this state because it should satisfy all the conditions. When we insert the q1, then at the starting the state will be in the initial state, that is q0, and when we insert the 1, then it will changes the state from q0 to q1, and when we insert the another one, then it will changes to the q1 to q2, and when we insert the another one, then it will be moves to q2 to q3. Design finite automata which checks whether the given binary number is divisible by 3 or not. Given that automata with binary numbers, so summation is equals to 0, 1. If a number is divisible by 3, the possible remainders are 0, 1, 2. If remainder is 0, then the number is divisible by 3. Consider step q0 as strings with remainders 0. Example 0, 1, 1, 0, 1, 0, 0, 1. q1 as strings with remainder 1, q2 as strings with remainder 2, and in this the initial state is q0, and the final state is also the Q naught. And this is the transition diagram for this solution, and we have to write the five tuples of this diagram and the transition table for this diagram. Here, design finite automata which accepts even number of zeros and even number of ones. String, the possible strings are L of m is equals to double one double zero one zero one zero 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 one 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 zero double one zero one. And the number of zeros and ones will be same. QNAT acts both as initial and final state. Design finite automata to accept the string that always ends with double zero. A string always ends with double zero, therefore possible strings are double zero, one double zero, one zero, one double zero, double one double zero. And in this the initial state is Q0 and the final state is Q2. Design finite automata which accepts set of strings. An integer consists of only number of numbers from 0 to 9. And here the initial state is Q0 and the final state is Q1. Design finite automata for recognizing identifiers. In this, the initial state is Q0 and the final state is Q1. That's all about my topic. Thank you.